All right. Hi, Joe. We don't know if this is working or not, but we'll find out. All right, here we go. I will check your homework in a couple of minutes once we start practice problems, okay? All right, so we talked about the difference between interpolation and extrapolation. Let's talk y on x versus x on y. Okay, so if you looked at this little icon here, this kind of organizes everything you need to know about the two types of regression, okay? So if you're calculating the linear regression equation, y equals, that's considered a y on x regression, okay? You're minimizing the vertical residuals from each data point to the trend line. Versus x on y, now your equation looks like x equals, and you're minimizing the horizontal distance between each data point and the regression line. So a lot of kids are always like, can you just switch x and y like an inverse and solve for y or whatever you want to do? You can't just switch x and y because you're minimizing two different things with the loss function that calculates the least squared regression equation, okay? So you can't do that. You got to run them as two separate variables. So you'll notice that like when you set up your regression in here, right, you still have your x, y list. And in here, you have x goes with x, y goes with y, because that's like the most traditional y equals mx plus b equation on a line that we know. Versus the other way, when you have x on y, you just switch the x's and the y's. Now your y's become your x's, and your x's become your y's.
But
Okay?
if you were to graph it, would it look like the inverse?
Not necessarily. We can graph the first example, and I'll show you the difference, right? Both lines pass through x bar, y bar. So this is the mean of all the x's, this is the mean of all the y's. Regardless of which regression that you've done, R doesn't change. R still measures the strength of the linear association between the two variables, okay? This, be careful with this, because you'll see that if you get the regression equation here, you get the regression equation here, carefully you have to type this guy in relation mode because he's going to be x equals, right? And if you see where they cross on the graph, it's going to be different from when you calculate two variable statistics for x and y. And that's because your calculator is rounding. And sometimes it rounds so much that you might not get the point on the IB exam. So I'll show you what to do in order to work around that and make sure you get the right numbers, okay? All right, here we go. I used to have a cute Kahoot, but he's gone now. Okay, let's go to example 1. It says, the following table shows the amount of fuel, Y liters, used by a car to travel certain distances, X kilometers. Okay, get your calculator open and ready to go because we are going to be spreadsheeting it up today. Whoop, whoop. In your X list, while I wait for my stuff to load up, in your X list, type in the 143580, that thing. In your Y list, type in the fuel used, okay? You're going to find the correlation coefficient, try to get the regression equation. Notice how this is Y equals, that's your Q, that it's Y on X, traditional linear regression that your computer always spits out, okay? Oh, I'm up. Hi, Joe Paz. We hope your doctor's appointment is going well. I'm just talking to you while I enter these in. I guess I could talk to Lucas. He's next to me, too. All right, so now we're going to find the correlation coefficient. You guys remember how to do that? I like to do it in a new tab because I have so much chaos in my life. I like to minimize it if I can. This is y on x, traditional equation. And then just take note that when you save the regression equation to a var, this guy's called a var, just put a little note in here because it might save you some time later, okay? What I mean by that is, oh, you're just going to be annoying? Okay. That's fine. You can be like, F1 is the regression equation. Okay. All right, so saved it. Okay. Find the correlation coefficient.
put the unrounded version first. You only have to go one digit past what you would round to. It just has to show like your rationale behind rounding. And hold on, let me move this. I'm frozen. Okay, I'm back. All right. The data can be modeled by, did someone just say my spell check? Oh, is it haunted in here? The data can be modeled by the regression line with equation y equals ax plus b. Write down the value of a and the value of b. So a is going to be your slope. So you got a equals 0.101003. Therefore, a is 0.101. Look, we're cutting off all those digits. That's why when we graph these two lines, if this was like, oh, where did like the x equals and the y equals cross? You can't just use the parameters that you found because you rounded it, okay? All right, so now you got b. It's approximately 1.96. All right, use the model to estimate the amount of fuel the car would use if it has driven 55 kilometers. Okay, so do you guys remember how I told you that when you save the regression equation to a var, you can just like super easy substitute values into that var? So easy. Look. So you're now evaluating F1 of, let's see what 55 is. Kilometers are my x's. Okay, perfect. So I'm going to substitute in a 55 everywhere I see an x. Right? That's like what we would be doing. But if you are like in here, do you have a question? Are you good?
How do you do like the bar stuff?
I'm going to show you right now. I just want to make sure we don't move before you're on the bus. You're on the bus? You're good? Okay. Okay, so now if I wanted to just evaluate a stored variable, that's what var stands for, right? We saved the regression equation to F1, so now I can just substitute in this guy for F1 and get out my answer. Whoop, saves you a bunch of time, right? Or, I mean, if you want to just like do it the old school way, you can totally do it the old school way too. Would you get the same thing? Probably. Okay. So if you want to do it the same old way, right? This was the regression equation. It was 0.101x plus 1.96. Now you're going to substitute in a 55. Okay. Who likes the var trick?
So it automatically stores it for you?
Yeah. And look, it did it. Come on. 7.52. Let me rate it. Come on. Okay. Well, this thing. So this is why, like, you got a little bit of a different answer from using the equation, but if you showed the unrounded output, then you would earn the mark for it matching your output. Does that make sense? Like, if it shows that you stored it as a variable, you're like, okay, I got that, and that's what the calculator gave me. And then if you show it with the equation, it gave you a little bit of a different answer, but because you showed how you got there, you earned the marks. Does that make sense? This thing does not like me changing any sort of color today, so sorry. These notes are plain old sad boring. Okay. Question 2. Okay, this is what I've been kind of warning you about with all the stuff. Here we go. A painter is estimating his new fees, and so he registered the time it took to paint different areas. The data is shown in the following table. All right, so we got our X, we got our Y. Let L1 be the regression line of Y on X. The equation of the line L1 can be written in the form Y equals AX plus B. Good, so they gave you so many clues here. They're like, this is going to be a Y equals equation, right? Let L2 be the regression line of X on Y. So in X on Y, the equation of line L2 is written as X equals CY plus D. Okay? So what you're going to want to do is put X and Y in as a list, and we're going to do our first switched regression together. Excuse me.
If they're not like order, like increasing or decreasing, does that matter? Or will it automatically like calculate stuff for you? Like you know how it goes like from 110 to like 22, and then back.
Oh, it puts it all in order for you, which is
Okay.
awesome. Okay. I'll wait till everyone's like in so you can see. So it looks like A and B come from L1, and then C and D come from L2. So let's do L1 in its entirety first, and then we'll do L2. All right, so L1 is Y on X. Let's do our regression for that first. That's your traditional setup. Okay, so I'm just going to leave myself a little trail of breadcrumbs here. Okay, so I've got L1. This guy was stored in F1 just in case I need that later. I don't think I will though. But his equation looks like Y equals, and then it looks like we've got 0.1343185x plus 3.30013. Okay, and then now I'm going to show my rounded. Okay, so I'm like, all right, this is my stuff. This is what I got before. Yep, looks good. Okay, so now this is L1. So A is 0.134, B is 3.3001. Okay, find the value of R, the correlation coefficient. Oh, that's right here. 0.976. And that came from, oh wait, no, this is the rounded version. And that came from, what? Oh, I'm gonna go back after I do like, that all comes from L2. So I'm like doing all of L1 stuff first, and then I'll go back and do L2. So R is 0.97618, that was unrounded, okay. So this is for this guy here, I have A, I have B, and that all came from L1. All right, I'm going to switch colors and do L2. Okay, so L2 is of the form X equals. So this guy is X on Y regression. When you set this up, it's literally the same, but you just switch the X's and the Y's. That's it. So you do menu 6, 1, 3. This is my Y. This is my X. And then he got saved to F2. So, all right. Okay, so now I have 7.0954945x minus 19.173. Okay. Now my rounded. Okay. So that's for L2. Looks good. Okay. A and B went with L1, so C and D are going to go with L2. And then just double check he's the slope, right? Yeah. And then T is... Did anyone just see that? A kid just walked by my door, but he was walking like sideways like this. Anyway, okay. So the lines L1 and L2 both pass through the same point with the coordinates PQ. Gee, if two lines pass through the same point, wouldn't you like and you have them as F1 and F2, wouldn't you just like want to just graph them and see where they cross? Of course you would, right? But yeah, I just pulled it from the first one because then it was like taking care of more problems at once. But like in my deepest soul, I just want to graph them and see where they cross, right? Well, we have to make sure that we're pulling it from the mean of all the x's and the mean of all the y's because these two lines are supposed to cross. So I'll show you what happens, right? So what you should do now is calculate two variable statistics because two variable statistics simultaneously calculates one variable statistics but for an x and a y. I'll show you what I mean. So follow along with this because it's a little different, but same idea, right? Menu, 6. Oh, well, if you do it on a graph, grid, it's going to be like different strokes. But you basically want to get to statistics, stat calculations, and then two variable statistics, okay? All right, so now your x list is x, your y list is y, and you just hit enter. This works and can save us time because we have an even number of n's. All right. Or not even, but matched. Like they each have a match, you know. It could be even or odd. Okay, so now I'm going through here, and what I need is x bar, y bar. Okay? So from two variable statistics, I found x bar, y bar. So x bar is going to be 90.08333. And then y bar, you're going to have to scroll down. Where are you at? Where are you at? Did I pass you? I did. It's 15.4. Okay. Now show your rounding. And then let's match the structure. This is P, this is Q. Therefore, P is 90.1 and Q is 15.4. Okay, so if you do the var trick and you graph them both like you probably want to, you see where this guy crosses this guy. The numbers aren't going to quite add up the way you want them to. So I'm going to suggest that you do two variable statistics to make sure you get the numbers right all the time. Okay, oh, those are different numbers than that. Oh, this guy, he needs to be put into relation mode, right? Because he's an x equals. Okay, so we would do x equals, and then all the parameters from L2. Oh, so this guy should be x equals. Get out of here. And this guy should be y equals, okay? All right. So we've got x equals 7.09. Y minus 19.2. All right. Oh, man. Let's add a bunch of stuff over here and a bunch up here. There we go. So you see how it's really close, but it's not hello? First of all, it's clunky trying to find it. Second of all, it's not even. I just had their intersection. Where did it go? You guys saw that pop up, right? Where'd it go? Well, now I just adjusted this. Okay. So we've got, this is an awful lot of time spent showing you the wrong way to do something because I don't want you to do it this way, but you know, here we are. Okay. That's not right either. What happened here? X equals, oh my goodness, this should be a 7.09. Okay. And it moved the other one too now. All right. I need a fresh restart here. And now it's bothered me, so now I have to do it. So hold on. So this is going to be my F1. Okay. And then the next one is going to be relation mode. X equals 7.09 times y minus 19.2. Okay. There we go. I knew I had to do it. Okay. So these are like really close, but not exactly what you wanted to do, right? Yeah.
So I did linear solve and got something like really close to that. That's what you guys.
Linear solve. Oh, you typed it into linsolve on the
Yeah.
calculator page?
Yeah.
All right. Yeah, that's the exact same thing. It's just finding where they cross.
Yeah.
But if you do 2-bar stats, you'll always get the right numbers. Okay? Aren't you so glad I spent all that time doing you want me to do it? How I don't want you to do it. Okay, perfect. Okay, so now let's go to the next one. What's up?
On the homework,
Uh-huh.
question number 2 is the same one we just did.
Oh my God, is it? A gift for you. Wait, really?
Yeah.
Question 2.
On page 99.
It's 6 employees and how far they live from work.
The numbers are different?
And then the numbers are different too. Yeah. Hey, you know what I like about you? You work smart, not hard. Let's see if we can find the repeat and then we don't have to do it. Smart. All right, let's go to example 3. So a class is given 2 tests, test A and test B. Each test is scored out of a total of 100 marks. The scores of the students are shown in the following table. All right, this looks like it's about to get real hairy. So I'm going to label this as my X and this is my Y. Okay? All right. How do I know it's real hairy? It's just a whole page. So let X be the score on test A and let Y be the score on test B. The teacher finds that the equation of the regression line of Y on X for these scores is Y equals, okay, look at your, like, use your clues, right? This is traditional regression. They gave us Y equals, good, cool. They gave it to us. Find the value of Pearson's product moment correlation coefficient R. So you're just typing these in and finding R. Easy money, we can do that. Did anyone go trick-or-treating in the weather? Yes! I took my kids. They were such little champs.
What was your kid's costume?
My son was a Ninja Turtle. He was Leonardo, to be specific. And then my daughter was Mira from K-pop Demon Hunters. Am I saying that correctly? Mira? I don't know. I had to make her like that sword thing that they have. That's like a long-handled sword. And it looked so bad. And she's so sweet. She like didn't care. She's like, "Oh, it's okay, mommy," but it was like awful. It was like, and it was raining, so the paint was like dripping down the handles. It was like really depressing, but she's a good sport. All right, I am just gonna double check I put everything in right. Okay. Okay. Sorry, I just like zoned out. Okay, we're finding R. Great. All right, did you guys get 0.901? I think I was doing it, but I definitely wasn't thinking about what I was doing. I was like off in space. Okay. There's no way in heck this is still recording. Yeah. Maybe. Oh, it is. Hey, Joe Paz. All right. Now, Giovanni was absent for test A. Okay, they're starting to get crazy here. So test A is which variable? Just put it under so you can keep track of it. And Paolo was absent for test B. Why? The teacher uses the regression line of y on x to estimate the missing scores. Paolo scored 10 on test A. The teacher estimated his score on test B. Okay, so he used his score on test A to estimate his score on test B to be 27 to the nearest integer using the following calculation. Okay, so he subbed x in to the linear regression equation that was given above, right? It was an x, he put it in for x. Okay, so that's not the problem. It looks like there's going to be a problem, right? Give a reason why this method is not appropriate for Paolo.
Because of different tests.
It's not a different test because it said it was for x, which is test A, and we put it in for an x, right? I don't know. What do you think?
Just like that extrapolation thing, like 10 is squared to
Yes, very good. Extrapolation. So it's out of the realm of the data that we've examined and generated the model for, right? What did they get? A 10. That's awful. That's way below everybody else, right? So we would say that's extrapolation. 10 is way below the rest of the test A scores. So do you see how it's like the model is for a certain span of data? That's what the model was made out of. When we start adding stuff that's really low or really high, remember regression is not resistant to outliers. It like changes the whole model. So we can't use a model for this set of data when we got a piece that's all the way over here, right? All right, Giovanni scored a 90 on test B. Okay. Test B was a what, an X or a Y? Okay. The teacher estimated his score on test A. So hang on, they took a Y and they used it to estimate a, okay, to be 87 to the nearest integer using the following calculation. Okay, where do you see that regression equation above? This is what? This is Y on X, right? But they're doing the opposite, right? They're setting it equal. Now you've done that in like A1 and stuff, right? But that's because you didn't know. Now you know. So, yeah, so you can say you can't use a Y on X regression to predict an X. That's like what you would say. Use an appropriate method to show that the estimated test A score for Giovanni is 86 to the nearest integer. Okay, so who's got an idea of what we can do here? What do you think? Yeah, right? So you can estimate an X by using X on Y. So let's go ahead and go back to our stuff here. And we'll switch them. All right. So now, okay. And then now what was he? Use an appropriate method to show the estimated test A score is 86. What was his? Oh, we got a 90. Okay. So 90 is going in for Y. And then you could just do the math. All right, and then we have to show it's 86 to the nearest integer, and it rounds to 86. Okay. All right. That's all I got for you. You guys can start your homework if you want. What's up? Yeah. You guys don't have to ask to use the bathroom. You can just go. You're not like my ninth graders where it's been like 20 minutes and I'm like, I see them outside. No. I'm trying to see if there's anything that might trip you up. We could do 6 together if you want. 6 is hard. I don't know if you'd be able to get there on your own, maybe. Do you guys want to do 6 together and then you can start the other stuff? Or do you want to warm up a little first and then we can do 6 in a couple of minutes? What do you want? Okay. Do you have a question or is this an emphatic yawn? The world's most emphatic yawn. Oh. All right, here we go. We're at 6. I'm going to clear out all my stuff because this looks confusing. All right. A jigsaw puzzle consists of many differently shaped pieces that fit together to form a picture. Jill is doing a 1,000-piece jigsaw puzzle. She started by sorting the edge pieces from the interior pieces. Okay, wait, I'm sorry. I have to stop because I just bought this game called Go. Has anyone ever played the Chinese game Go? Yeah. Okay, I don't know how to play it, but I want to learn. Is it fun?
I've never played that.
Okay, I have one coming from eBay. Maybe at the end of the year we'll play it or something. I don't know. I'm very excited. They're like these tiny little glass things. I think my son's going to eat them, so I have to bring it to school. Then I can bring it home when he's older. But I want to learn. It looks fun. Okay, so she started by sorting the edge pieces from the interior pieces. Okay, so it sounds like we're starting to make a problem out of this, right? We've got edge pieces, X, interior pieces, Y. 6 times she stopped and counted how many of each type she had found. The following table indicates this information. Imagine doing a puzzle and deciding to do linear regression. Fascinating. All right. Jill models the relationship between these variables using the regression equation y equals ax plus b. Okay, what type of regression is this? Y on x. Okay, so we're just going to calculate it the traditional way, right? Let's go ahead and put it in our calculator, okay? Well, I feel like I have to qualify. My son would eat them because he's 4, not because he's like... You ever see that show, My Strange Addiction, where people like eat couch cushions and stuff? Yeah. So that's why he might eat it. You've seen it? Kirsten's seen it.
I like seen it on TikTok, like I never watched the actual show.
Oh my gosh. What's crazy though is like sometimes on that show they would eat stuff that like would kill you. They like eat.
One time I watched an episode of a lady that was obsessed with eating her husband's ashes.
Joe, pause the video. See what you miss when you're absent. Oh my god. That's like Ozzy Osbourne level. What is going on? Lucas has a follow-up question.
Is that considered, well, that is considered cannibalism, but how cannibalistic is
Oh, that's dark. Okay, so we got our equation. And it says write down the value of A and B. A is 6.93, B is 8.81. Stop, you like hate when I change colors and I can't handle it. Okay. Okay. Use the model to predict how many edge pieces, what are edge pieces? X or Y? She found when she had sorted a total of 750 pieces. Gee, what is a total of 750 pieces comprised of?
X plus Y.
Yes. Okay. We want to find out how many edge pieces, or X, she found in 750 pieces. Do we have another?
Old equation.
Well, we have another equation that models interior pieces as a function of edge pieces. So couldn't we technically just graph them together and see where they cross? We could. Mikey's nodding with the most serious face you ever saw. He's like this. You could graph them. And then we'll talk about what we're actually looking at when we graph them, okay? I don't want to be in relation mode anymore. Do you guys know how to change out of relation mode? Because you can't use the table in relation mode. But I don't think you can use it if one is in relation mode and one's not. Can you? You could. I already typed it in though. It's all right. Stop yelling at me, Peyton. No. All right, I can't see a darn thing. Let's see if we can zoom fit. Oh my, I gotta add some things over here. Ah, there we go. Okay, so when these cross, what is this telling me?
Is it like the X value of the intersection? Is how many edge pieces?
Yes, okay, copy the point down and let's chit chat. You're on to something. Okay, so this is gonna round to, because we're talking about like pieces of stuff, so I'm just gonna round it to 93 and 657, I guess, okay? When you add those two numbers together, what do you get? 750, right? This is an X. What does X stand for again? Okay, and then this is a Y. What does Y stand for again? Okay. So, when she sorted a total of 750 pieces, how many edge pieces did she find? There you go. All right. I think you will definitely be able to handle the rest then. Okay, bye, Joe. We're kicking you out.